I'm here with Lupe. In this video, we will simplify radical expressions and expressions with rational exponents. The concepts we will use in this video include simplifying radicals and working with the rules of exponents. So here is a radical expression, and we want to simplify it. This happens to be a cubed root, not a square root, so we have to be careful about that. And what I'm going to do is, we're used to simplifying square roots, but let's look at when we have numbers underneath the radical and it's a cubed root. Let's just come on over here and make a factor tree. This is the way I like to do it, and that is breaking it down. So let's break down 27, 9, and 3, 3, and 3. Okay, we've broken down into all prime numbers 27. Now here's the trick. Instead of having a pair come out of the radical, we need 3. 3 of those prime numbers need to be together to come on out of the radical. So let's do that. Guess what? The cube root of 27, I have 3 3's, they can all come out as 1. The cube root of 27, as you might know, is 3. So now we just have to worry about the x's. So here we are, we took out everything that we could from the radical from the number, and that was everything because 3 3's came out. And now we'll look at x to the 7th. Now here's a trick. I'll give you a little trick. If you take this exponent and you divide it by the index, this is called the index, then you will find how many times you can bring the x out. 7 divided by 3 is x squared. What's the remainder? 7 divided by 3 is 2. 2 times 3 is 6. Ooh, there's an x left over. I'm going to do this in another way, and just to show you if it's under the radical, and you could break it down. X, 2, 3, 4, 5, 6. Oh, 1, 2, 3, 4, 5, 6, 7. Now, same way, if you want to break it down into prime factors, you need 3 of them to come out. So 1 and another one came out. That gives us an x squared. What didn't get to triple up with anything? The x. So 1x remained in the radical. In fact, you could even erase it. There's your answer. 3x squared times the cube root of x. Here's another one. Now we could do these all day and with all kinds of combinations, but if you practice and you get these simple tools, it's like doing a puzzle. So let's do this puzzle. Let's start with the number. It's the 4th root of 16 x to the 6. We're going to simplify it. What can we pull out using the numbers first? So let's go 16. Let's break it down. 8 times 2. 2 is done. 4 times 2. Oh, look at this. 2 times 2 times 2 times 2 is 16. That's 2 to the 4th power. Well, if you've got 4 of them, they can all come out with nothing left over. So guess what? The 4th root of 16 is 2. So I'm just going to pull that 2 out here, and I'm done working with the numbers. Now I've got to worry about the variable. I'm going to leave a space because some of the x's might be able to come on out here, and some have to remain inside the radical. So that's a 4th root, and I'm going to use my little trick. I'm going to take 6 divided by 4. 4 goes into 6 how many times? 1 time. 1 times 4 is 4 with how many left over? The remainder is 2. That's my little trick, and it works. Every time, divide the exponent by the index, you'll get an exponent here, multiply, get the remainder. Sounds confusing. Takes a little practice. Here's something fun, and it's a really useful tool that you'll need in the near future. This is a rational exponent. This is a rational exponent expression. And we can use a simple process to turn it into a radical expression. So we're going to go from rational exponent into radical form, and we can go back and forth depending on how we need to work the problem. It's just a simple tool. So here we go. We're going to take the index, or the part that goes right inside this little area here, is the denominator of your rational exponent. So the 3 comes on in here as the index. And now I'm just going to put parentheses around that entire radical expression. And this numerator of my rational exponent is going to come on out here and go squared. So the way to change from rational exponent form to radical form is a pretty simple process. Let me show you another one. How about x to the 3/4 power? That is in rational exponent form. And we just use the simple rule. The 4 goes in the index. It's the denominator of the rational exponent. And the 3 comes on out here to the side. And that's an x. Let's do another one. How about, this is a really popular, I know you already know it. X to the 1/2 is the square root. The 2 goes here, but we don't write that because that's a square root. I could kind of write it, but I'm not going to. And there is a 2 there, and it's raised to the 1 power. So actually, this is a really important one. X to the 1/2 power is the square root of x. How about this one? What's x to the 1/3 power? Well, Mr. Fulmer, that's the cubed root of x. Very common expressions. Now here is an excellent example of why you might want to change forms of these expressions before you simplify them. Now here we have an 8 to the 5/3 in rational exponent form, and for this problem I'm going to change it to radical form before I simplify it. So let's just do that. That becomes the cube root of 8 raised to the 5th power. All I did was change forms, and now I'm going to look at this a little bit better. It's a little easier for me to see now. I know that the cube root of 8 is 2 because I've been practicing these things, and the cube root of 8 is a real good one to know. The cube root of 8 is 2. So I'm just going to replace that. Cube root of 8 is 2, and I'm going to take it to the 5th. 2 to the 5th. 2 times 2 times 2 is 8 times 2 is 16 times 2. 32. Uh-oh. We have a number raised to a negative rational exponent. That's not going to scare us one bit. I don't like negative exponents. So I'm going to change this and see if this helps me. 1 over 27 to the 1/3 power. That's going to help me a little bit. I have a negative exponent, and I'm just going to move that on down to the denominator and make it positive. And now I'm going to use my trick for, let's look at 27 to the 1/3. Maybe it'll be easier to see if it's in radical form. So let's see. 1 over the cube root of 27. Cube root of 27, that's manageable because I don't have a calculator right now. And I'm going to take that 27 and I'm going to break it down right here. 27, 9 times 3, 3 times 3. Look at that, 3 3's and nothing else. The cube root of 27 is 3. 3 times 3 times 3, 27. And so that gives us, don't forget, 1 over 3. Looking pretty simplified to me. Wow, there are all kinds of fun things on this topic. Look at this one. This one's using the rules that you know about exponents when you have two bases multiplied, you add their exponents. So we've got 12, and we're just going to add the exponents. And thankfully, there's a common denominator. So 1/2 plus 3/2, we can just add the numerators. So that equals 12 to the 4 over 2, or 12 to the 4/2. Or you can simplify that. 4 divided by 2 is 2. That's 12 squared. And all of a sudden, 12 squared is 144. Here's a great one that really uses a lot of cool little concepts. So we've got a base divided by a base and they're raised, and you remember from the rules of exponents, we subtract. So we have 8 to the 1/3 over 8 to the 2/3. We subtract the exponents. 1/3 minus 2/3. Well, you could just do the subtraction and get a negative rational exponent and then move it to the denominator, or you can just keep it in the denominator. I'm going to do that one little extra step. 1/3 minus 2/3. So I'm just going to say 8 to the 1/3 minus 2/3. And that's 1 minus 2, and that's a negative 1/3. So that's an 8 to the negative 1/3. I don't like those negative exponents. So I'm going to say that's 1 over 8 to the 1/3. That doesn't look completely simplified to me. So I'm going to change it to radical form. 1 over the cube root of 8. Ooh, and this is starting to look really nice because I know from lots of practice that the cube root of 8 is 2. Wow, that would be tricky if I didn't know the cube root of 8 is 2. I could do a factor tree, I guess. Don't have much time for that. Here are some great problems for you to try. Now, the best way to do these problems is write them down and try them on your own. After you do that and you've tried every problem, then continue watching the video and you'll see my quick solve of these problems. You don't want to go straight to that part and just watch the quick solve, because that takes away the practice, and the practice is what's going to help you get these problems right. Remember, the more you practice these problems, the more you get them right. And the more you get them right, the more confident you feel about math. And the sky's the limit.